Hello friends, this video on magnetic effects of current part 7 is brought to you by examfear.com. No more fear from exam. Let us now look at magnetic field due to a current carrying solenoid. Before that, let us see what is a solenoid. Now, solenoid is nothing but a coil which is wound into a tightly packed helix. What is a tightly packed helix? It is nothing but something in this pattern. Suppose if you have a coil which is wound very tightly in this pattern. So this pattern is known as a helical pattern, like this. So this is called an helical pattern. So if you have any coil which is in this pattern, it is known as a solenoid. So now we will see what kind of magnetic field is produced with a current carrying solenoid of this form. So let us look at this. Now it has been observed that with solenoid also the same experiment was done. Some iron filings were taken and then they were placed on the solenoid, and then it was found that they arranged themselves in a specific pattern, and it was to our surprise that it was seen that the pattern of magnetic field lines in case of a solenoid was similar to that of the bar magnet. You remember the magnetic field lines pattern in case of bar magnet? They look like this, right? They originated from one pole and terminated to the other, and they form closed continuous loops. So by looking at this pattern of magnetic field, it was then told that one end of the solenoid behaves like a magnetic north pole and the other end of the solenoid behaves like a magnetic south pole. That means a solenoid is not a bar magnet, but the behavior of the solenoid is similar to bar magnet to some extent, and therefore one end of the solenoid from where the magnetic lines are assumed to initiate, that is known as the magnetic north pole, and the other end where the lines seem to terminate is known as the magnetic south pole. So here also the magnetic field outside formed this kind of curved loops, and inside if you see the magnetic field lines are from south to north and they are uniform. If you see the magnetic field is uniform, it is in this fashion, right? Now, field inside the solenoid, field is uniform inside the solenoid. This is a very important property which has been put into various useful applications, right? So here we saw the pattern of the magnetic field, right? And as far as direction of magnetic field lines is concerned, that is simple. As the direction here it will be the field lines originating from north poles terminating in south pole as far as it is concerned outside the solenoid, and inside the solenoid the magnetic field is uniform and it is directed from south pole to north pole. Now let us see, where do we actually use these solenoids? What are their applications? Well, they are one of the most important applications are in electromagnets. What are electromagnets? They are specific kinds of magnets which are extremely useful for practical purposes, like in case of electric motors or electric generators. We often use these kind of electromagnets. So solenoids are actually used in electromagnets. How? A strong magnetic field, as I mentioned in the last slide, that the magnetic field inside the solenoid is uniform and it is strong. So this strong magnetic field produced inside solenoid is used to magnetize magnetic material like soft iron when placed inside the coil. For example, you have this material, soft iron, okay? You put this material inside this solenoid. So since inside the solenoid you have a very strong magnetic field, therefore this material gets magnetized. So that means the magnetization of this material increases, and such materials are then known as electromagnets. Electromagnets are those magnets which have very high magnetization, right? So that they behave as even stronger magnets. Right, so in order to make electromagnets, we make use of solenoid. Here you can see from this diagram that this is a solenoid. Inside the solenoid you have placed the soft iron and then you have connected it through a circuit. Now as current passes through the solenoid, magnetic field is produced in the solenoid, and magnetic field inside the solenoid is uniform and strong. So this magnetic field magnetizes this material, right? It is also found to be useful in transformer creation. You all are aware of the name transformer. Maybe you are not aware how a transformer actually functions, but you would know what is a transformer, right? Most of you would have seen transformers outside your houses near the electric poles and all, from where the electricity comes to your houses. So these transformers also make use of solenoids. Here if you see, they have got these solenoids with the help of which actually the transformation of the current and voltage takes place. Now how this transformer works, that we will discuss in our later classes. So for now you should just know that solenoids are useful in these transformers also.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.